Hi grade 10s. I'm going to try this video again because the first one died and then I was very sad because I was like halfway. But here we are. And this video is on kind of like a revision of trig. It's from that exercise on page 107, the revision exercise. So I'm not going to do every single one, but I've picked out an example of each basically to do with you guys. Okay, so the first one, they give you a triangle and they ask you to calculate x, and then they ask you to write these three as a ratio on this triangle. But what I just wanted to run through with you guys one more time, just to see if you remember, cot is the same as 1 over tan. And we know that tan is opposite over adjacent. So if cot is the inverse of tan, it's the inverse of opposite over adjacent. So it becomes adjacent over opposite. Same thing with sec. Sec is the inverse of cos. Cos would have been a over h. So now it becomes h over a because you have inverted it. So therefore you must invert this as well. Same with cosec. It becomes 1 over sine. So instead of it being o over h, it becomes h over o. Okay, so if you get asked about cot, sec, or cosec, you're going to have to use these ratios. Basically, the inverse of tan, cos, and sine. Okay, now, calculating x, that's fairly simple because it's just Pythagoras. So you're just going to have x squared equals 8 squared plus 15 squared. So x is equal to the square root of 8 squared plus 15 squared. So x equals, and you guys can do a calculator, 8 squared plus 15 squared gives me, that's wrong, 15 squared gives me 17. Okay, so now I know this over here is 17. Now I need to come up with ratios for sine, sec, and tan. So sine is always opposite over hypotenuse. Here is theta. Opposite is 8. So it equals 8 over hypotenuse is 17. So that's no problem. Then sec theta. Sec is the inverse of cos. So it is h over a. From theta, hypotenuse is 17 over adjacent is 15. Okay, I hope that makes sense. And then lastly, tan theta, that's simple. Tan theta is opposite, which is 8 over adjacent, which is 15. Opposite over adjacent, which is 8 over 15. Okay. Alright, I hope you guys don't mind if I move this up. But my arm is getting really close to the tripod thingy. Okay. So this over here, they gave you a table and you had to fill in the respective ratios. The first one, even before you get started, I want you to notice that there are 3 triangles here. There's PRS, that smaller triangle. There's this one over here, RQS, and then there's the big one, PRQ. So they've given you all 3 triangles. You're going to have to work with the different triangles. So just be careful because this line is the hypotenuse for the big triangle. But this line is the hypotenuse for this triangle. And this line is the hypotenuse for this triangle. So you must just be careful about which triangle you are in. What I'm going to do is, to make it a bit simpler, I'm going to highlight the triangle that we're working with. So the first triangle they're talking about is PQR. PQR. So I'm going to highlight PQR. Okay, so in PQR, we're first working with sine alpha. Here's alpha in the big triangle. This alpha is in the little triangle. You can see it's only that small. So we're working with this one. So sine will be opposite, which is that line, RQ over hypotenuse, which is PQ. Here's your big one. Okay. Cos of alpha will be adjacent over hypotenuse. Adjacent is this one over here, PR over hypotenuse, which we've established is PQ. Okay, then theta. If you're looking at theta, theta is now on this side. This one was alpha, so now we're looking at theta. They want tan of theta. So it's opposite, which is PR, over adjacent, which is RQ. Okay, and then over here they're asking for cot. Now just to help yourself, remember cot is adjacent over opposite. Okay, so now you're looking for adjacent over opposite. From here, adjacent is RQ. Excuse me. Over opposite, which is PR. Okay, so that's everything in the big triangle. The next triangle is PSR. Find another color. I like colors. PSR, which is here. Now you're in that triangle. Okay, so for this one, they're asking about sine of alpha. Here's alpha again. Clearly that alpha does not form part of this triangle. So sine is opposite, which is now clearly RS, over hypotenuse, which is PR. You with me? Then cos of alpha is adjacent, so it's PS, over hypotenuse, which is PR. Okay, now we're dealing with theta, which clearly in this triangle, here's your theta. So it's opposite over adjacent. Opposite is PS, adjacent is RS. And cot is the inverse of tan. So it's adjacent over opposite. So it's actually just this one inverted. You'll notice with this one as well, it was just that one inverted. But anyways, adjacent is RS over opposite is PS. Okay, so that's that one done. Let's do the final triangle. Using pink. Okay, now it's going to be sine of alpha, so it's opposite, which is SQ, over hypotenuse, which is RQ. Remember, we're working in this triangle now. Then cos of alpha is adjacent, which is RS, over hypotenuse, which is RQ. Okay, then tan of theta, you're now working in this corner. Tan is opposite, which is RS, over adjacent, which is RQ, or QR actually, sorry guys, I should probably put these in alphabetical order, it looks nicer. And then cot is the inverse, so it's adjacent over opposite, so from theta, adjacent is SQ, over opposite is RS. Okay, I think that's pretty straightforward, so if you wanted to, you could pause and make sure you do it yourself. I just want to make sure I put the paper back in the shot. There we go. Cool. Now, let's move on to the next question. Alright. So now, this was the stuff with the sketch. Okay. This one is even simpler. I don't know if you guys remember, but last time we had to try and decide which quadrant to draw the sketch in. This one, they've just shown that sine is positive, but they don't give you any extra information. They don't say like cos is negative or whatever the story is. So you just know that for this one, if they don't give you other information, you're going to draw it in the first quadrant. Okay, so your triangle is just going to look like that, with your right angle, and this will be theta. Okay, so just remember that if it's positive, they don't give you any extra information, just draw it in the first quadrant. Okay, so remember sine is opposite over hypotenuse. So from here, opposite is going to be 3 and hypotenuse is going to be 8. What's your next step? You need to calculate this. Okay, in order to do that, we just use Pythagoras. This is a side. So side squared equals hypotenuse squared minus other side squared. So side equals the square root of 8 squared minus 3 squared. So side is equal to square root of 8 squared minus 3 squared is, okay, it's a square root of 55. I'm just going to leave it in third form. We leave it like that. So this is root 55. And remember, the other thing you always have to check is after you've worked it out, is it negative or positive? Because if your triangle was on this side, for example, that would have to be negative because x is negative. So just remember to go and double check that. Okay, now the actual question was to find cos times sine theta. So you can't actually find anything until you've drawn your sketch. So cos theta times sine theta, cos is adjacent, which is root 55, over hypotenuse, which is 8, times sine is opposite, which is 3, over hypotenuse, which is 8. And then that you can just do on your calculator. Root 55 over 8 times 3 over 8, which simplifies to 3 root 55 over 64. So it actually doesn't simplify. Okay, cool. Does everyone understand that? I hope you do, because I can't hear you. Okay. Next one. I wanted to do this one because I don't actually recall showing you an example where there was a cot or a sec or a secant involved. Okay, so what I want you to do for this is immediately go and rewrite this in terms of sine, cos, or tan. Okay, so if you recall, cot is 1 over tan. Okay, cot is 1 over tan. So what they're saying is, over here, 1 over tan theta is equal to 1. But I actually want tan theta at the top. I want it to look like this. So if I then go and put tan theta at the top, tan theta over 1 is just tan theta. This 1, I could put it over 1. If I flip it, it's still 1 over 1. So that's basically going to stay the same. And leave it in a fraction form because it makes it nicer when you are trying to make your sketch. Okay, so this is now what we're going to work with. Now remember, I said to you, if they don't give you any information, you're just going to draw it in your first quadrant. Okay, so I'm drawing in my first quadrant because it's positive and they didn't give me any other info. So it looks like that. Okay, here's theta. Tan is opposite, which is 1, over adjacent, which is also 1. Look at the fraction, it's 1 over 1. So my hypotenuse is just going to be, so hypotenuse squared equals the square root of 1 squared plus 1 squared. Oh, sorry, hypotenuse is the square root of 1 squared plus 1 squared. So hypotenuse is just square root. 1 squared is 1. 1 squared is 1, so 1 plus 1 is just 2. So this is the square root of 2. Okay. Alright, so now we can go and work out 1 plus secant squared theta. So like I said, when you see these things, go change them for me. This is the same as 1 plus, or you can even just use the ratio immediately. Remember, secant is 1 over cos, which is hypotenuse over adjacent. So when you fill this in, you're going to write hypotenuse over adjacent. So let's look here. Hypotenuse is root 2, adjacent is 1. Root 2 over 1 is just root 2. And then you must just square the whole thing because it is to the power of 2. So this just becomes 1 plus root 2 over 1 is root 2. Squared is just 2. So the answer is 3. Okay, and that's your sketchy ones. Yeah, sketchy ones. Okay. Number next. Okay, I think I left out number 5. I can't remember why. Let me just double check. I don't know if it was easy or... Oh, it's your special triangle stuff. I'm going to let you guys use your calculators for now. I know it's cheating, but yeah, no one really checks. But I also want to rather go through that stuff when we get back. Okay, so number 4. If A equals 70 and B equals 33, tan A plus B, blah blah blah, you must work out these. Okay, this is just calculator work, guys. It's so easy. All you're going to do is instead of the A, you're going to write 70. Instead of the B, you're going to write 30. So this is tan of 70 plus 30, which, oh sorry, not 30, 33, which you can do on your calculator. Tan of 70 plus 33 is negative 4,33. Okay, that's all they want you to do. If they don't say anything about not using a calculator, that's you're just going to use a calculator. Okay, they're saying cos, so it's cos squared of A, which is 70, minus sine squared of A, which is also 70. By the way, don't ever get freaked out with the fact that the square is here. What it just means is cos 70 squared. So when you type it into your calculator, it's just cos 70, close your bracket, squared. Okay, simple as that. Minus sine 70, close your bracket, squared. And that gives us negative 0.77 if I round it off to 2 decimal places. Okay, last one, secant of 3a over 2. Okay, now just go and double check. What is secant? Let's check it. It's 1 over cos. Okay, so that's all you're going to do. So you're going to write 1 over cos of what they are asking. What are they asking? 3a over 2. So it's 3 times a is 70 over 2. Okay, so now you just type it in exactly like that. It's 1 over cos. Then you're going to have another fraction in there. 3 times 70 over 2. Close your bracket. And your answer is, I'm going to round it. I'll use my S to D button. So it's minus 3, 8, 6. Okay, so when you do have a sec or something, you just write whatever was here. Okay, you write it in when you invert it. So you write 1 over cos of that thing, and you can just punch it into your calculator. Okay, number 6, solve for x. Now this is very simple. Remember, when you're trying to find an angle, this is when you must shift. Okay, so for a, sine x equals 0.678. So therefore x equals shift, which gives you sine inverse 0.678. So check. Shift sine of 0.678. Oops, no, it wasn't shift. Shift sine 0.678. That gives us 42.69 degrees. Remember to put degrees because that's an angle. So just remember, you want like a sine by itself, a thing by itself on the side. Then to get the angle, you must just shift. Okay, here's number D. D was 3 plus sec x equals 5. Okay, so to get the sec alone, because remember you want that thing by itself, you're going to take the 3 over. So sec x equals 5 minus 3, because you take it over, it becomes the opposite sign, which is just 2. Now, yeah, you're working with sec, you don't like sec. Okay, so you can go and you can change this to cos and then just invert it. So, okay, I'll show you the in-between step. So, 1 over cos x equals 2, right? Because these two things are the same thing. Sec is 1 over cos. So if I want cos to come to the top, I must invert this one. Now this one's over an imaginary 1. So if I invert 2 over 1, it becomes 1 over 2. You with me? So x is then going to be shift cos of a half. So shift cos of 1 over 2, which is 60 degrees. Okay. Running out of space. Okay, so with these ones, I want you to be careful. You might be tempted to want to take that minus 60 over, but just understand it's in this bracket. It is part of the angle, so you can't move it yet. Okay, so what's going to happen is this whole angle, 2x minus 60, is equal to shift sine of 0.2. So the answer that you get for shifting that side is the whole angle. So let's check it. So shift sine of 0.2 is 11.5. So what it means is 2x minus 60 is equal to 11 comma 5, 4. Okay, so 2x equals, now you can take the 60 over, 71 comma 5, 4. And then if you divide it by 2 to get rid of the 2, x is 35 comma 77 degrees. Okay, I'm just rounding everything off to 2. The point is, guys, if you have, like over here, it was 3 plus secant. So sec must stay by itself on this side. You can take the 3 over. But when your angle has more than one thing, you can't take it over until you're done shifting. Once you've shifted, you can take everything over. Okay. Next one. Getting tired. Okay. Find unknown sides. Let's get a different color. Okay, I'll go back to orange. Find unknown sides. Now, this first one's very simple because you can just use, oh, actually, no, I lied. You can't use Pythagoras. If you had another side there, you'd be able to use Pythagoras. So it's like, now what? How do I find this missing side? Okay, we have done this in class. I remember before we left. What you need to do is look at the angle that they've given you. Okay, look at what you have and look at what you're trying to find. In terms of this angle, this is opposite and that is hypotenuse. So which ratio do you know that deals with opposite and hypotenuse? What would be? Sine. Sine of your angle equals opposite, which is, we know, is x, over hypotenuse, which is 17. This is an equation. X is at the top, 17 is at the bottom. How do I get rid of 17? If I take it to that side. It is being divided, so I make it a times. So sine 31 times 17 equals x. So x equals sine 31, close your bracket, times 17, which is x is 8 comma 7, 6. Okay, they'll usually give you some form of unit like centimeters or meters or whatever. Just make sure you include it. I don't think I copied it down. Okay, D from 7 was about finding the missing angle. Now you still do the exact same process. You check what you have, but remember, when you're finding an angle, you must make sure that you shift at the end. So in terms of x, this is adjacent, that is hypotenuse. So adjacent and hypotenuse, we know it's cos. Cos of x is adjacent, which is 4 comma 3, over hypotenuse, which is 9 comma 7. If I want x alone, what must I do? Shift cos of this thingy. So x equals shift cos. So shift cos 4 comma 3 over 9 comma 7. Okay. Because I made a weird thing. 63 comma 69 degrees. Okay, easy, easy. Alright. The last questions, I think I actually gave myself extra paper and I didn't. Okay, this question, I'm not going to fit it on here, so I'm just going to write it on the back of here. Thank you, Unisa, for all the paper. Okay. Alright, so with this one over here, they sort of guide you to the answer. They tell you that, let's move this up. Okay. They tell you that M is the midpoint of this over here. And the first thing they want you to calculate is this length. They want that length. Now look at the triangle that you're working with that length. It is right angled. So that's cool, so we know we can use trig ratios. We know an angle, we have a side, and we're missing a side. Okay, so just check what you are missing. You've got adjacent and you're missing opposite. So what deals with adjacent and opposite? Tan deals with adjacent and opposite. So it's tan 21 equals adjacent, which is 12 over opposite, which is MB. Okay, so to get MB, now don't go and times this side by 12. MB is at the bottom. See this happen all the time. If you take MB to that side, it becomes MB times tan 21. Because MB was at the bottom, you're left with 12. Now take 12, tan 21 to the bottom, because it's being timesed. So MB will be 12 over tan 21. So MB equals 12 over tan 21, which is 31,26. Okay, so this is 31,26. Okay, next they want AB. They want this whole line, which is simple because they've told us this is the midpoint. So this must be half the length of this whole line. So we just have to times it by 2. 31,26 times by 2. 62,52. With me. Okay. So this whole thing is 62,52. Okay, now they want angle ACB. We need more highlighters. Okay, this is your triangle that you're now working. Okay, they want this angle, that whole angle C. So you need to again go back and use your trig ratios. You want this angle, you have a 12, you have a 62, you have this whole length, we just worked it out. So in order to get this whole angle, you must think, this is opposite, this is adjacent. What deals with opposite and adjacent? We know it's tan. So tan, I'm just going to call it angle C, tan of this whole angle C equals opposite, which is 62,52 over adjacent, which is 12. So to get C, I must just shift tan of that whole thing. Just write it in there for me. So angle C is shift tan of 62,52 over 12, which is 79,13 degrees. How awesome is that? Okay, so now we've got that whole angle. Now lastly, they just want AC. Now AC, you can just go and do Pythagoras. You've got this length, you've got that length, so you can just do Pythag. So AC equals the square root of, remember it's hypotenuse, so it's the other two sides plus. So it's 12 squared plus 62,52 squared. So AC equals, I think I'm becoming untidy, I'm sorry, I'm getting tired. 62.52 squared. Okay, 63,66 degrees. Okay, so just to run through what I did again. First thing they asked was for MB. I used my little triangle. I had 21, I had a side, I was missing a side. I could use tan because it's opposite and adjacent. To find AB, M was the midpoint, so I multiplied it by 2 to get this whole line.